Hey everyone, and welcome to Full Stack Dart with Firebase Functions. I'm Rody, a developer relations engineer at Google, supporting many projects at Google, including Flutter. The most popular multi-platform app development toolkit is used by over 1 million active developers. We run everywhere: mobile, web, desktop embedded, and so much more. Everywhere you want to draw pixels. Your first question shouldn't have to be, where do I want to run? But rather, what do I want to build? There are many great companies building with Flutter, which include Google Earth, Google Cloud Mobile, NotebookLM, and so much more. When building apps at scale, there's a constant tension with putting the business logic in the client or the server, and the right decision can change as features evolve over time in an application. There's always going to be trade-offs. We want that optimistic instant UI on the client, but we need that rock-solid, private, and secure logic on the server. We love backend as a service because it helps us get to our MVP faster, but scaling it becomes a real challenge. If you're trying to build offline-first apps, or you're not familiar with building a backend, you end up putting a lot of logic on the client. If you do have a backend, there's probably places in the app where you're validating on the client when you should be protecting it on the server. Client-side checks are great for UX, but they're fundamentally insecure. Server-side rules can lock things down, but they're not as flexible as the validation and logic that we had on the client. Because of this gap, you end up maintaining the exact same business logic in totally different languages. Drift isn't a possibility here, it's an inevitability. You can also try to keep the clients lean, but by putting everything into the cloud feels like a downgrade. You take your nice, perfectly typed, null-safe Dart models, rip them apart, and translate them into TypeScript and Python. Your rich Flutter app devolves into a shiny, dumb terminal waiting on a black box backend. But now, you're writing docs twice, syncing mobile and backends twice as well. It's a communication overhead that robs you of time that could be spent building features. And in 2026, more places that you have with duplicated logic across languages can be room for errors and oversight when working with coding agents. It's hard to beat a single source of truth. And that brings us to Dart. Dart is the language that you use to build Flutter applications. It's also the language that we use to build all but the very lowest levels of Flutter. The power of Dart language, the libraries, and the runtime are what give Flutter its amazing development lifecycle, tight native binaries, fast startup, and smooth animations. But Dart isn't just the language for Flutter apps. It's a powerful, flexible, modern object-oriented language that runs everywhere that Flutter does, even in places that you don't care about pixels. Dart also powers all of the tooling in the Flutter ecosystem. The static analysis, the thing that gives you the red squiggles, that's all Dart, and the formatter too. Even our web compilers for both JavaScript and WebAssembly are written in Dart. In fact, Dart is so flexible that we're able to implement the lowest level of the Dart language, the lexer and the parser, in Dart. That way we can compile those bits to native code and embed it in the C++ native runtime and the compiler tools. But not just the tools on your development machine. The Dart and Flutter teams have also been running Dart on the cloud for years. Our packaging site, serving those million-plus monthly developers, is all written in Dart. When you want to try out Flutter for the first time, which we hope you will, go to dartpad.dev. You can then build a Flutter application right in your browser. And then the backend handling the interactive compilation is also pure Dart. Guess what? All of the language and runtime features that make Dart amazing for performance for mobile apps, our strongly typed null-safe language, and our ahead-of-time compilation, these also make Dart a great language for Google Cloud Functions. The Dart SDK is big. We have a lot of great tooling, static analysis, real-time analysis, compilers for x86, ARM, RISC-V, JavaScript, WebAssembly, and so much more. Your server application likely has dozens of transitive dependencies that all talk to the cloud services that you use. And yet, we can still generate a tiny native binary that deploys in seconds and cold starts in milliseconds. Unlike JIT-compiled languages that need to warm up, and we all know that pain, Dart's native execution springs to life fast. And when you scale up fast, you're also free to scale down to zero, meaning you don't pay for services that aren't being used. And this brings us to Firebase. Firebase makes it easy to get your connected application from idea to reality. Authentication, messaging, and Firestore, dozens of powerful features backed by the power of Google Cloud. Flutter and Firebase are like chocolate and peanut butter across mobile and web. Firebase helps you take your beautiful Flutter user experience and turn it into a beautiful connected experience. But there's been a gap, and we've heard about it for years. What about functions? Why can't I take my Dart skills and the blazing fast Dart runtime into my Firebase functions? Well, today we're thrilled to show you. We're unlocking a truly symmetric development experience. Kill the context switches between languages and tools. Stay in your IDE, stay in Dart, and stay in the flow. Full stack Dart is here. And we're moving beyond just painting beautiful pixels and handling your mission critical domain logic with Google's massively scalable infrastructure. Now, Google Cloud Run didn't go add another special use case for Dart in their list of supported languages. They did something better. Cloud Run now supports OS-only runtimes. This means you can compile and deploy the server binary right from your development machine, or more likely, your CI/CD pipeline. Google provides the base OS, in this case Ubuntu, and packages your binaries and assets on top. You don't have to have Docker on your dev machine. You don't need to wait for Google Cloud Build either. On your Windows workstation or your Mac laptop, Dart supports compiling to AMD64, which is a Linux binary, for deployment in seconds. So how do we do this? First, let's look at the problem. Right now you've got heavy business logic, complex validators, or sensitive API keys baked right into your Flutter app. That bloat makes your bundle massive. And second, exposing proprietary IP or the keys in the client is a security vulnerability waiting to happen. And finally, the update trap. Need to tweak a small rule? Enjoy submitting a patch and waiting for the app stores to review and waiting for it to fully propagate. Let's start with an example Flutter developers are intimately familiar with, the famous default counter app. It's a great way to show off state management, theming, and widget composition. Today, we're going to make the counter app work across all connected clients and have a globally incrementing counter with as minimal code changes as possible while staying in pure Dart. We first need to create a pure Dart shared package. This will be your home for all the reusable models across your Flutter app and Dart functions. We should not depend on Flutter here. Since Firebase Functions compile to AOT, it will not have Dart UI. This will be your ultimate single source of truth. Your data models, enums, and core domain logic, all of it lives here. This is your universal translator. Both your Flutter app and your cloud functions import the exact same package. Firebase Dart functions are built on top of Shelf and make it easy to return JSON from responses when we call them. We can convert Dart classes to JSON with the JSON serializable package. We can also store a constant here for the callable function name that we can use to define the function itself and reference it later when we call it in the app. Run the build runner to generate the files, and now it's time to create the Firebase function package. Just like the other supported languages and Firebase functions, we can just run the Firebase init functions command to generate and create the package for us with all the boilerplate needed. Select Dart in the dropdown and make sure you're on the latest version. If you don't see Dart listed, make sure you run the experiment referenced in the docs. Once you do that, make sure you've added the shared package that we created earlier as a relative path reference. We can update the default Dart function code to this. It should look very similar to you if you've worked with Firebase functions in other languages. The request and the response come right from Shelf and work as expected. The basics of this code is setting up a Firebase HTTP request trigger with the increment callable function variable we defined earlier. We then can increment the count from Firestore and return the increment response. This should feel like a normal Dart code for Flutter developers, and you can put anything here that you don't want exposed on the client. And that's it for functions package. We can then start the emulators if we want to test it offline and make changes locally. Or we can deploy it with a single command, Firebase deploy. Now going back to the Flutter app, we can just update the main function to set up Firebase function emulators. Make sure to match the port numbers for the emulators from the ones we defined earlier when creating the project. Now we can update the increment logic in the app. We need to add a loading state and get the current functions URL by passing the increment callable variable. Using the HTTP package, we can just call the function like any other REST API and use the exact same increment response class that we used on the server to parse the response body. And after we get a result, we can update the count and reset the loading state. Now we can update the counter logic. Or rather, we don't. Nothing has to change here, and we're done. We can run this on any platform that Flutter and Firebase support, and the count will globally increment across all connected clients. So why is this cool? True symmetry, pure Dart, and end-to-end. It's one set of tools, one set of packages, one set of agent skills. Shared code, shared business logic, and no more fighting between implementations to keep your business rules in sync. Better security. Keep your clients thin, and it keeps your secrets on the cloud where you have total control. And over-the-air updates without any App Store reviews. It's also local first. You can spin up the Firebase emulator suite and test your entire architecture perfectly offline or on an airplane before you even pay for a single cloud invocation. And we wanted a zero friction DX. We've integrated natively with all the tools that you already use. Deploy without the DevOps. There's no custom Docker files or IAM docs. It uses the Firebase CLI that you know, and deploying your Dart backend is exactly the same. Firebase deploy. So where are we today? We're super excited to announce that we're officially in experiment. We're kicking off with HTTPS on request and on-call function triggers, as well as emulators and Firebase deploy. If you want to try out building the functions today, then check out the code lab that we just published called Deploy Dart on Firebase Functions. At Google, we don't build in a vacuum. We need you. Your feedback is the absolute most critical part of this experiment. Please download the examples, try out the code lab, and experiment with adding Dart functions into your app today. In conclusion, it's one language, one logic layer, and one unified stack. Thank you so much, and we genuinely cannot wait to see what you're going to build with Dart on Firebase.